Okay, so here is the actual sample project that I opened under our GL262 Labs example subfolder. It's named Lecture 17 Texture, and here I already opened the solution file. So this is the main driver program right here. As all samples, we just have one single implementation file that contains all the functions that interact with OpenGL and other libraries. Then I went into the subfolder under models, BMP, these are bitmap files, and created this test BMP using Paint application like this. So this is, you can see that this is actually 512 by 512 size bitmap image. And it can be large or small. The way our bitmap loader works, just make sure that the image you're using has sides and pixels that are multiples of 2, like 512 by 512. And the image doesn't have to be square. For example, it can be a rectangular shape, like this. Okay, let me just change the zoom level here. See, it's rectangular. You want to look at the proportions of it. It's 512 by 855. And also it can be small, like this. So for instance, this one is really tiny image. So let's just take a look at the size, and this one is just 24 by 24 pixels. So we can of course try to zoom it, and you can see that this is just the size that we get over here. Just make sure that when you save your image like this, when you say save as BMP, just make sure that you specify 24-bit bitmap image format, or else the loader in our laboratory project may fail to recognize its internal format and the program may fail. So let me cancel this, and so let me try running this project real quick. I already built it, so I'm using test.bmp and press Ctrl F5 to run it. So it loads the model of the cube and applies this image as texture to each side. As you can see here, also if we look at the top of the cube, it's also applied to every side the same way. The only other part that I had to change here, because this example doesn't calculate frame per second rate to control the animation, I had to change the rendering function. So I'll show you where the rendering function is. And of course everything here is in one file. So I just had to reduce the increment of the theta angle, which animates the rotation of the cube. So I'd like to show you a series of updates that took place here in this project, specifically related to texture handling using OpenGL calls. So first of all, let's just go to the top of this file and simply search for an update. All right. So okay, one more time. So the first update is that we now have new handles or new unique identifiers. The first one is the texture buffer ID, which is the piece of hardware responsible for storing texture in GPU memory. But it is not the same as vertex attributes buffer. This is internal organization of GPU memory, and the internal storage of texture inside the GPU will be different compared to the original two-dimensional array of colors. We also have the texture coordinates, so we need to use this to activate the new vertex input attributes, which is UV coordinates in our vertex shader. And we also have texture ID, which is a special type of uniform inside of our fragment shader that we need to activate so that it can start sampling the colors from our texture object. We also have the image data, which is the raw pointer to an array of colors that we load from our bitmap file. Alright, so let's look for the next update. So this is happening in our main function right here. So basically the new part is that we have to load the UV coordinates into the graphics card, and this comes as part of the vertex attributes. So we actually have 8 floating point numbers, positions of our vertices XYZ, normal vectors also specifying XYZ vectors, and UV coordinates, which actually become ST coordinates on the fragment shader side, but we'll discuss this later on. And so this is another buffer subdata call that takes the array of UV coordinates, the texture coordinates, and loads them as part of the vertex attributes. The next set of updates is dealing with the fact that we have to load the bitmap file. So let's take a look at that real quick. So this is the implementation of bitmaploader as found on the open source to parse the structure of 24-bit bitmap file, and we'll discuss the structure of this loader when we talk about our next laboratory exercise. So let's go back to updates. Okay, so the next update I'd like to show you after loading the bitmap file, we come to this section that's shown on the slide. So let's discuss all of this OpenGL API in our next video.